My name is John Mayo. I'm a professor of economics, business, and public policy in the McDonough School of Business at Georgetown University. I'm also the executive director for the Georgetown Center for Business and Public Policy, which is our co-host for today. We are thrilled to be co-hosting this event for the fifth time with the Wireless Technology Association. It is a treat to do, and it has become, I think, part of the very important dialogue that is happening in Washington surrounding the advance of technology and the role of public policy. All too often, people in policy settings don't really understand technology, and maybe even the other way around, it's true as well. That technologists don't quite understand the policy world. So this, we believe, is a really important springboard for an important dialogue that can happen in this city. We're thrilled about this and thrilled about the partnership. Today's event is entitled Massive Broadband Network Densification, Unleashing the Opportunities of 5G. I didn't know what 5G was a couple of years ago. We're getting closer to understanding what 5G is. I'm not sure we're all the way there, but today we're going to get even closer yet. Today's event is in modern fashion being tweeted about, and you are welcome. Please, let me encourage you to tweet, I guess it is, the hashtag GTown Policy. Hashtag GTown Policy, hashtag 5G, and let all those other people know about what's going on here. So with that, let me hand it over to my partner in crime, Peter Rasavi.
Hi, it's a pleasure to be here today. As huge an impact as 4G LTE has had on the economy and how people run their lives, how they socialize, the impact of 5G will be far greater. We're at a time when we're looking at a convergence of multiple technologies and market factors. One of these is just the densification of fiber, extending the fiber backbone ever closer to all endpoints. From a wireless perspective, we're at a point where we're ready to commoditize in huge numbers the ability to use spectrum that has always been problematic and difficult in the past. And I'm referring to millimeter wave spectrum that technically goes from 30 gigahertz to 100 gigahertz. But in today's cellular and Wi-Fi networks, we have about a gigahertz of total spectrum. The amount of spectrum relates directly to the amount of capacity, what kind of speeds, and what you can do with it. With millimeter wave, we're going to be able to harness 10 times as much spectrum and ultimately even more than that. From a market point of view, we have trends of cutting the cord to broadband, cutting the cord to our TV. All of these things are happening kind of in a limited fashion so far, but the capabilities of 5G will accelerate these trends. Part of using these higher bands and part of how we achieve these great increases in capacity will be through small cells. And in fact, we have small cell equipment here that one of my panelists, Mobility, will be explaining once we get to my panel. But these are going to be crucial towards achieving these extremely capable, extremely dense networks that are going to create a broadband fabric that we'll have access to from anywhere and that will enable applications that we can't even conceive of at this point. So with that introduction, I'd like to invite my panel to join me here at the table. I'm pleased to have Art King from SpiderThought Wireless, which is now part of Corning, Rob Howell from Comcast, Marc Kuduk from Nokia, Jason Ento from Mobility, and David Wolcher from AT&T. I'm going to put down this mic and assume that I'll get activated on the other one. Oh, are we short seats?
There you go.
Oh, that works.
You're the moderator after all.
I am the moderator, so I should have this high position here. Oh, actually, I think I'd rather sit down. We're just going to go from down the table here. I'm asking the panelists to introduce themselves, what the position is in the company, and just the role of their company relative to this topic of broadband densification, and any other comments you may wish to make for maybe about 3 minutes.
Okay.
Yeah, if you ramble too much, I'll stop you. So
Okay.
Go ahead.
So SpiderThought Wireless builds indoor cellular RAN equipment for operators to procure and enable services inside buildings. Many office buildings are underserved markets as far as signal because business case doesn't work. There's not enough subscribers, for various other issues. And as 5G becomes more and more important, those signals won't penetrate these buildings, so signal will have to be delivered inside the building by somebody. And we see a very interesting market evolving out there, and there's quite a few research topics that I'm sure that our colleagues on the panel will talk about that are going to influence what we eventually actually build as a production product for the future. And my background, I came from global operations for a multinational, and I was actually attempting to be a buyer of this technology back before I flipped over to this side of the business. So,
Okay, great, thank you. Rob?
Good morning, I'm Rob Howell, and I run our Next Gen Access Architecture Technology team at Comcast. Obviously, we're a wireline provider. However, of course, as we go forward, we have to think about what other technologies are going to be relevant to us to serve our customers at the end of the day, despite all the really cool stuff I'm surrounded by here. And I used to run a millimeter wave group about 10 years ago, so it is really cool stuff to me. I have to deliver to the customers we have and think about how we make the best network for those customers going forward. And any technology, any access technology, any last mile, be it air, copper, wire, we have to consider those options as we think about our strategy. So that's what we do. I'm sure you've all heard of our company, and if you are one of our customers, thank you very much.
Thank you.
Okay, good day. I'm Marc Kuduk. I'm a wireless researcher with Nokia. For those of you who are not familiar with Nokia, we're a cellular infrastructure provider providing the networks, the radios that supply all the major operators here in the US and throughout the world. Nokia considers a bit of a brain trust of consolidation. We are a consolidation of all the former network arms of Nokia Networks, our namesake, Siemens, Motorola, where I joined in, as well as Alcatel and Lucent earlier last year. My job, what I do is I am a wireless researcher in a small cells research group, part of Bell Labs Research. We are working on the 5G standards right now. We do the system simulations and the network investigations, and actually write the standards for 5G. And 5G is going to be very exciting. We have an opportunity for new types of applications into new vertical industries below 6 gigahertz, and there's opportunity to use an incredible amount of spectrum that has its challenges, but it's very exciting in terms of what it can deliver to the customer.
Thanks, Mark.
Good.
Jason.
Thanks, Mark. I'm Jason Ento. I'm the Senior VP for Network Strategy at Mobility. Mobility is a network infrastructure provider in that we work with carriers, public entities, venues to build out infrastructure to facilitate high-capacity networks. And so that could take the form of a sports stadium, a transit system like Seattle Sound Transit, or a city. And so for about the last 2 years, we've been really working on small cell deployments throughout the country, mainly focused on the major cities across the US, where we're really kind of at that nexus of public policy and working with cities on what that public policy needs to be to facilitate rapid broadband deployments. Technology distribution, so working with Nokia and some of the other OEMs to deploy their technology. And then really getting stuff done. So truly deploying things in city rights of way, in building and elsewhere around the country.
Jason, do you want to say something about the gear you brought? We always love showing
Yeah,
that.
so one of the things that we find, particularly in panels, is to just make this a little bit more concrete, is what is a small cell? And so to your left is an example of it's actually Nokia equipment. Thank you, Marc. Which one of our customers, Sprint, is deploying throughout the country. And so you've got an antenna on top. You have a second antenna, which we'll talk about a little bit later, I think, which is called UE Relay, which is a wireless backhaul. You have the actual small cell, which is that small box in the middle, which is the actual transmitter and receiver. And then you've got a very small kind of power distribution panel. And so the reason why we bring this, and this is what what we call a naked small cell looks like. And to the right is, if you can picture all of that equipment except for the top antenna put in there, that's what's called the New York shroud. And so every small cell in New York, regardless of what carrier it is, goes in that box. It's what was approved by the New York Arts Commission. And so we find that it's useful to talk about this in really very concrete terms. This is what we're talking about. This is what a small cell looks like, because we find that there's a lot of reactions to what this means. And so, and lots of the concern about it is aesthetics. So we just want to demonstrate what that is. And my guess is only about half of you noticed it when you came in terms of it actually being there. And the other half of you are now seeing it and going, yeah, what's the big deal? So so we'll talk more about that as a panel.
It's not
they're not
on right now, right?
Right. Right.
And if it is, what's the transmit power?
Right. Yeah. Our joke is no, it's not going because it hasn't been through all the tribal processes it takes to get that going. So
okay. Thanks, Jason. Dave.
Good morning. My name is Dave Wolter. I lead the radio technology and RAN architecture team at AT&T Labs. Most of you are probably familiar with what AT&T does. My team is primarily focused on sort of the 1.5 to 5 year kind of time frame. So we look at technology, new technologies, technology evolution, do a lot of analysis, simulation to understand what the performance of those technologies are going to be, as well as subject matter expertise for much of our standards work. So we've been very involved in 5G NR for quite some time now. We've also been conducting lab and field trials using millimeter wave systems for fixed wireless at this point, as well as doing some drive testing. So we've got a little bit of experience in what this can do at millimeter wave and some of the issues involved. We're also quite interested, of course, in what can be done in Sub6 GHz band. Some interesting problems for us to solve in terms of evolving our spectrum into the use of this next generation. And my team also works with our regulatory team on spectrum issues.
All right, excellent. Well, I'm excited because I feel like with this group of experts, there'll be an answer for no matter what question I ask. The questions I have, and I'll have questions till about 9. We'll have a panel discussion that I'll lead till about 10:45, and then we'll see what questions there may be from the audience. I've been researching and have issued a number of reports recently that seek to quantify the capabilities of 5G networks and how they perform relative to wireline networks. And the projections are truly staggering. What we'll be able to achieve with these next new networks is going to be really, it's going to be amazing. It's not going to happen instantaneously. It's going to take a long time. It's going to take the 2020s to roll out all this new infrastructure, and I want to discuss that with the panel. The questions I have fall into general 4 major categories. One is just what are the technology and deployment trends occurring in broadband in general, not just wireless, but wireline as well. What is going to enable these ultra-dense, ultra-capable networks is extension of the fiber that we have. So the second category of discussion is just about fiber densification, because you can't make all this wireless work without the fiber. All of this wireless technology is not going to replace all the fiber in the ground. Ultimately, one fiber strand has something like 100,000 times the capacity of all RF spectrum. So what we're really trying to do is get the fiber close to the people and then look at the best access technology. In a lot of cases it will be wireless, but it won't always be wireless. Rob, I'm sure will say it depends.
You have wired.
Right. So I mean, there's but the trend is fiber. And then we'll have discussion about some 5G specific items, such as standardization, some of the key aspects and capabilities of 5G that make these ultra-dense networks possible. And then the fourth category of questions will be around spectrum. How do we make use of this new spectrum? What does it mean? Where is that spectrum? And how will 5G not just use new millimeter wave spectrum, but how can it take advantage of all existing spectrum? So my first general question is just, what do you see as some of the most significant trends in broadband networks? Kind of open-ended, and anybody can answer that, whoever jumps up. Rob.
Sure. To make sure my wireless friends don't get to talk very much. No, I'm just kidding. So, the big trend that we're dealing with all the time, and you mentioned it up front, is just this persistent compounded annual growth of traffic. It's been there since the dawn of the internet. It's 40-50% per year towards our customers, a little lower than that in what we call the return path from the customers, but it's still growth. So you're constantly needing to keep track of where that trend's going. It's been consistent, so that's helpful that it's consistent. You can make projections and invest accordingly for that. That's a big one. The gigabit, the term gigabit has become the new benchmark for data services. I think it's fair to say it's not all demand driven, but there is certainly some demand for gigabit from our customers. So we deliver that with our DOCSIS services beginning, I guess, early last year. The latest emerging new thing is what's going to go on with IoT. It's a different sort of traffic model, but lots of new devices chattering very often. We have to think about that from what that impact of our network is there. So that's probably three of the big ones that we see. Streaming video obviously has been around for a while. I wouldn't say it's new, but it's a trend that's been very impactful to our business, not just from keeping our subs happy with our video service, but just the traffic load and the asymmetry of the load and how that grows over time we have to keep track of. And of course, from a service standpoint, we have to make sure that we're able to deliver a video service that is comparable or better, we believe better, than streaming services provide. So that's been a big impact, and that's still ongoing as well.
Yeah, so everything you said applies both to wireline and wireless.
Sure.
Yeah. Other comments on kind of the major broadband trends?
Well,
go ahead, Jason.
Definitely think what you're seeing in response to that is as traffic increases, is all of the major carriers, and I think to some extent you can extend this to the wireline provider as well. So how do you put together a network that can handle that growth, that has a 3 to 5 year outlook, and that really has more cost effectiveness in how it's handling that increase in traffic? And so certainly small cell, obviously kind of my view on that would be densification of the networks via small cells. And so certainly a huge trend in it right now is how do we go and deploy small cells and wireless nodes at a scale that's never been done before. And I think that's probably...
So what numbers are we talking about? Are we talking about hundreds of thousands, millions? Where are we heading?
I think we're talking currently about hundreds of thousands, and I think over time that grows into, if not millions, multiple hundreds of thousands over the for the foreseeable future as the carriers look to densify their networks to take care of, first and foremost, the capacity needs in the networks today, and then prepare for a 5G platform. And certainly, I think even with the wireline providers like Comcast, you see Wi-Fi nodes being, built out throughout the country as well. And so, I think, how do you have public policies that support that, and how do you have organizations capable of rolling that out across the country is a major trend in the industry right now.
All right. Well, let me dive into some specifics. As far as 5G goes, where are we relative to standardization? Do we know yet, Marc, what 5G is and what it looks like, and when can we start actually rolling it out?
I think we know a lot about 5G. In fact, if we look at the standards, 3GPP is broken up into releases. 3GPP is the standards body that writes the formats that we use for 5G. Given the interest in 5G, both in the US and in Japan and Korea, we started this process in this release of writing 5G. Next month, we should lock down the formats for the lowest layer, the physical layer, so we can start investing in those chipsets and ASICs that take a lot of NRE, a lot of investment to get small and get down to the right power consumption. Early next year, we should lock down the standard for non-standalone. What does that mean? That means 5G working with 4G together. So you have a multi-capable handset that will do both 5G and 4G. And we expect that those standards get locked down. All the details get written out by mid-year, the specific formats of all the messaging. And then that will enable us to about 18 months out, come out with 5G standard radios in about 2019 timeframe.
Okay. So Dave, as soon as 5G is available, you're going to rip out all your 4G stuff and put in 5G, or what's the plan?
I don't think we'll be ripping everything out. Yeah, we've gone through the standardization that Marc described in order to get the chipsets moving for NR, and our plan is to do an initial millimeter wave based NR deployment towards the end of next year. Very aggressive, but we're certainly trying to hit that. The other thing that was mentioned is, is with release 15, we have certain capabilities, most of it focused around the enhanced mobile broadband. With release 16, which is complete by the end of 2019, we'll really bring in some of the maturity around some of the massive IoT. And while a lot of the ultra-reliable low latency communication is scheduled for release 15, it'll kind of be more matured in release 16. So we have to remember that millimeter wave is not 5G. It's not just millimeter wave. We have both a sub-6 GHz and millimeter wave. And when you think about what this network has to be, it really needs to be a network of networks. So, as was mentioned, we'll start our deployments with non-standalone architecture, which allows the control signaling to go over the LTE and lower frequency bands we operate today, while data is going across millimeter wave to bring up the higher speeds and capacity. Eventually, as we go to NR and the lower frequency bands, it can become more of a standalone kind of architecture. And there are, getting back a little bit to the first question too, one of the reasons why we really want the millimeter wave band is that while everything in the home, we're going to the gigabit in the home and so forth, and why are we doing that? Well, it's not that people necessarily need gigabit service, but we've got everybody in the house looking at their own screen all the time, and an awful lot of that time is spent on video. Well, people are also wanting to do that when they're outside the house, right? So it not necessarily that there's going to be a particular application that requires gigabit rates, but we're going to have a lot of people requiring high day rates for 4K video, eventually 8K video, and so forth. And so we need to blend these, and we also need to bring in Wi-Fi. So indoor service, how are we going to do this? We need to think of this as a complete system and a complete experience. So it needs to be a multi-radio, multi-technology kind of approach.
Okay, thanks. Are there what are some of the other standards related to network densification that are playing a role here? So, for example, other important fiber standards. I know a little bit about NG-PON2. Other on the wireline side, other advances in DOCSIS. Can people comment on any of those?
Sure, I know a little bit about DOCSIS. So DOCSIS has been around for 20-some years, I guess, now, and I guess we're on the 6th iteration, I suppose. The 3.1 standard gets us to 10 gig on coax, basically, and the full duplex version, which is just now emerging, gets us multi-gigabit symmetric capability. So these are big numbers, of course. DPON, or in cable speak, there's 2 PON families, and they roughly track each other in rates. Most of the time when you talk to folks in the cable industry, we'll talk about EPON, so sorry for the slip there. PON in general is at the 10 gig point now as well. There's reasons for EPON for cable. It has to do with some standards that we wrote to help provision that service when it's used. But those standards for DOCSIS are certainly are meant to emulate what's available on fiber standards today. My friend down on the end with AT&T mentioned a really big piece of this, right? It's not just the big fat pipe we put in place. There's something has to digest that, right, in the home, and the home has to support that. So all of the home networking standards, the G.HN, the MoCA, which is sort of the coax version of G.HN, the Ethernet standards between 1 and 10 start to matter. Wi-Fi, of course, right? We have AC today, AX tomorrow. These are all going to have to collaborate or kind of align in time to deliver these kind of rates, not just to the home, but throughout the home. And as he pointed out, the applications are limited. We always kind of joke that one of the killer apps for gigabit is the speed test, because that tends to be what first thing people do when they get gigabit services. But it's the aggregation of lots of streaming and lots of capacity, not dragging down the data service browsing person that happens to be in the home while there's lots of video streaming. So it does all add up. So those are important standards. There's standards at the back end that are moving too, right? There's a lot of the densification comes with the need to support lots of fiber, lots of connections. So the backside of that means a lot of potential impact to facilities if you don't find a way to scale that logically and physically. So there's a lot of work going on the virtualization side, on the open source side, to try and make those architectures scale well as we grow more fiber into the plant. So those are as significant. The home stuff is as significant, and the access stuff, though, as our friend there on the end from AT&T said, all these things have to come together in concert for this to really play out well.
All right, thank you. Why don't we discuss spectrum, since we've introduced it for a little. What are the spectrum bands that are going to play the greatest role in network densification? It's kind of a fairly broad question, but anybody want to kind of tackle or maybe explain what are the current millimeter wave bands under consideration in the short term, and what other bands may become available longer term?
Okay, I can start. First of all, before we go into millimeter wave, we do have to mention that sub-6 GHz, we're going to be looking at 5G at 3.5 here in the US, 4.5 in Japan. So those frequencies where there's opportunities to aggregate up to 100 megahertz of spectrum will be ideal for 5G massive MIMO deployments. But that, of course, is 100 megahertz. When you start to look at these millimeter waves, you're going to 10 times that, around a gigahertz of spectrum at 2.8, 3 gigahertz at 39. So these great opportunities that these already are available, and we're already working to that for release 15. But even looking farther, you can actually look at bands even higher, up to 100 gigahertz, but we're looking at 70 and 90 gigahertz, where you get 5 gigahertz to 10 gigahertz of spectrum. We might see those coming out as study items in release 16, and then the work items hopefully in 17, with maybe deployment a few years after these initial deployments at 28 and 39. There's a lot of challenges here, though, of course. I mean, we haven't used these frequencies in the past because they're not easy to build cellular systems. As you go higher in these frequencies, you start to lose a lot of the propagation that we're used to. It doesn't bend around corners as easily. So these systems are going to be different. They're going to be primarily outdoor systems, and we're going to have to bridge that capacity from outdoor to indoor.
What about, Dave, you mentioned sub-6 gigahertz. What's your view on the role 5G plays in the lower bands?
Well, so there are a couple of things that, as we want to move to the next generation for increased spectral efficiency, which primarily is going to come from FD-MIMO in the sub-6 gigahertz bands. The other thing that we can't forget is some of the advantages that NR brings in latency. And one of the key reasons I think we want to deploy in the sub-6 gigahertz bands is to be able to provide the Internet of Things with either small amounts of data that may not be latency sensitive, but there are a tremendous number of them, so the massive machine type communications, and you need to do that in some way that's efficient. The other is the more critical or ultra reliable low latency communications where industrial control and these kind of things that need extremely low latency. We need to be able to do that. Now, if you're doing it only in millimeter wave, then your coverage is going to be somewhat limited, right? We're not going to go nationwide with millimeter wave, but we can go nationwide in a sub-6 gigahertz band. So when we think about AR, VR services, when we think about industrial control and automation, and massive machine type communications, all those things are required not just where traditional traffic is heavy, but across the country. So we do need to be able to deploy in the sub-6 gigahertz band to take advantage of those capabilities of NR.
Okay. Art, how do you see kind of the small cell deployments occurring indoors, because that's your area of focus, right? Versus outdoor. How is that environment different?
Well, indoors is this blessed area where you have power, backhaul, a controlled environment, and you don't have a bunch of neighbors complaining about that it's ugly. so it's kind of nice, and the pull is coming from a lot of major enterprises that really want this indoors. Mm-hmm. So we do see the trending that it'll probably be sub-6 gigahertz. It'll be potentially an overlay of the existing LTE installations that are going on today, and it'll just overlay into those infrastructures. And right now, our cell size is about 1,000 square meters, it's 10,000 square feet. So, at that cell size, 2 or 3 people can really use up 100 megahertz of capacity in a very nice way. And and we see work going on with the CBRS community so that the 5G.
Can you explain CBRS?
The Citizens Broadband Radio Service. It's a new shared spectrum strategy that the FCC is deploying out to the U.S. in 3.5 gig, and that area of 3.5 gig also needs some compatibility work to be done with 5G NR, so that everybody kind of plays nicely in the same piece of spectrum. Mm-hmm. Okay. So there's a ton of work going on the backside, but there's going to be a lot of. We think all the LTE networks that we're building today are just bricks in the foundation to add on to in the future.
So does millimeter wave work indoors, or does it?
We've seen models that it works, and it'll bounce around the corners and that type of thing. Mm-hmm. But we're working with very sensitive business cases where the idea of pulling yet more cables and adding in much more equipment in a denser fashion can smoke the business case. Mm-hmm. So there's two places the business cases get hurt indoors. It's radio density and just the sheer cost of backhaul. Because even millimeter wave, you can't go through the glass, so you have to deliver via fiber inside the building and then propagate via the radios in the building. So, the cost of backhaul is a very tough subject right now.
Well, backhaul is always tough as we densify. So maybe let's discuss the practicalities of deploying hundreds of thousands of small cells. What are some of the technical capabilities envisioned for 5G or planned for 5G that will simplify deployment, such as, is there anything in 5G that will make backhaul simpler to accomplish?
Yeah, one of the things that we've really been pushing in 5G NR is the fact that it's difficult to get fiber everywhere you want it, and sometimes in a timely fashion. And there's a cost to doing so. Particularly early in our deployments, you're going to want to deploy coverage where you don't necessarily need all of the capacity at a given time. And so one of the things that we've kind of developed and brought into 3GPP is called Integrated Access and Backhaul, IAB, or self-backhaul. So we've got millimeter wave systems with these antenna panels and the ability to steer beams. So while a given G node B can be steering a beam and...
A what?
A beam.
No, the G node B.
Oh, G node B, I'm sorry. So G node B is the new terminology because node B was taken, E node B was taken, so we have to have another one. I'm not quite sure where G came from. Okay. But, so you can steer a beam to provide access to someone, while at the same time you can seize the same time and frequency resources and steer a beam towards another G node B. And so you can use a wireless link to provide the backhaul for this particular G node B that's not attached. So this is something that we think is going to be important for the economics, particularly in the early deployments. And in general, just to get capacity in otherwise non-economic places to do so.
Yeah, Peter, I'd add, I think you're seeing a lot of acceptance of alternative ways to get backhaul even today. I think for all the reasons that we're talking about, it's tough to get fiber everywhere. We're coming up with new places where the small cells need to be located, and we're certainly G node Bs will need to be located for 5G purposes, where the capacity issue isn't somewhere obvious where you're going to be able to easily bring in fiber. So I think you'll see a much wider acceptance of wireless backhaul, and even I talked a little bit about the UE relay, even where you're using
Can you explain that? That's
sure,
an LTE capability.
Yeah,
right?
with the UE backhaul, effectively the provider slices off a piece of its spectrum from a serving macro site to serve as the backhaul, and we're seeing throughputs that are 100 megabits. So it's really kind of a neat way to get backhaul in a location where bringing in fiber, for example, would be prohibitively expensive or just really difficult to do. It'd take too much time. So I think you'll see a really wide acceptance of alternate backhaul, and it will be necessary for these deployments at these types of volumes.
Maybe to add to that, I think, is when you start looking at the millimeter waves, because you have this large amount of spectrum, you can imagine building out a network even if only 10% of your nodes are connected by fiber. So what you can do there is you can actually, a lot of simulations we've been doing for integrated access and backhaul, because that is going to be a very big item this next year for 3GPP, is you can take an area of maybe 25 cells and maybe just 10% of those, 3 of those nodes can be connected with fiber. And you can use that to improve your coverage. And that's effectively what you see. We typically look at key performance indications like what is my average user throughput? What is my cell edge throughput? So that's what 95% coverage reliability you can get. So if you had a choice where you can only deploy 3 5G millimeter wave nodes and look at that area in an urban block where you've got a lot of corners, things where you can't bend around, you're not going to meet any greatest service that you would really be willing to deploy. However, if you take that time and you deploy these extra cells, even though you can't get fiber to the majority of those cells, you'll dramatically improve your cell edge performance. It's a great way to bridge in new systems, generate the demand. There will be some costs. If you use integrated access backhaul, the latency will be a little bit higher. Fiber will always be better, but it's certainly one way that we can get to that coverage, make use of these spectrums, and the fact that we have 10 times the size of the spectrum makes it more realistic. And maybe one more thing to add is a lot of these cells that we deploy are going to be sectorized. That means I've got a panel on each side of the system. So I can actually be receiving backhaul on one side and then receiving UE traffic, user traffic on the other side. And you can actually make use of those panels, time sharing within the same spectrum.
So when we talk about small cells, what size how big are these cells? What are the practical limits with millimeter wave? How big, how small?
So when we do our system simulations, I think we've really tried to see how big we can make these systems. But typically the numbers that we've been simulating are about 100 meter site-to-site distance. That's a typical city block in Manhattan. We've gone to 200 and 300. What we find is that if you don't have a lot of trees and a lot of leaves, maybe you can go up to 300 meters site-to-site distance. As soon as you see a lot of obstructions where the signal has to pass through, the larger the distance, the greater the probability, the chances that you're going to actually be obstructed. And the challenges with millimeter wave is that you can obstruct the millimeter wave, people walking past you and signs. So you need some kind of diversity where you're going to get some reflections off of surfaces that are going to get you your signal. You go too large, it gets that much more challenging to develop that. So you're really talking about 200 meters site-to-site distance.
Just to be clear, for millimeter wave.
Yeah, I mean so you're talking about dozens. I mean, in my analysis, you end up with anywhere from like 20 to as many as almost 100 sites per square kilometers. That's a lot of new poles.
Yeah, and the importance for integrated access and backhaul, that self-backhauling concept.
Right. Jason?
Well, I was just going to add on the fiber considerations. The other thing that's very real in all of this is working with the cities that need to approve all of this. And so I was just going to add on that part of the reason why all of these alternative backhauls are really necessary is because we will have a tough time as an industry going in and saying, okay, I need to dig up first and main. And then the next guy comes in and says, I need to dig up first and main, and the next guy comes. So a lot of this becomes, hey, we need to stay really coordinated on that and have these alternatives that make it workable for the cities. Another example earlier, you were talking about standards. We can all come up with whatever great stuff we want to come up with. In New York City, if it doesn't fit inside of that box, right, we have to all collectively as an industry go back in front of the Arts Commission of New York and have them approve this for 12 million people. It's a tough sell. Right. So some of these standards are also, and I think the OEMs specifically are really mindful of this right now, which is terrific, of how do we do this so that we can make it easier on the folks that need to go deploy this in the field.
Yeah, in fact, when you asked that question, my mind didn't go to how big's the cell. My mind went to how big is the equipment.
Right.
Because it's a huge problem. I mean, you take somewhere like San Francisco or New York, where they're very strict about how it looks, how big it is, where you can put it. So the other piece that's going to come into all of this is we need to get really creative about stealthing all this stuff. Now, how can we make it blend into the environment? So it's not just necessarily even just a big box or a couple pieces hanging on the pole. As he said, in New York, it's got to be in that one item, so maybe it disappears a little bit.
As the technology improves, will it get smaller? I mean, in 2030, will the
equipment get smaller?
Be this
the antenna is the question.
The antennas, okay.
You've got some limitation on how small you can make that antenna and still get the gain that you need.
Right.
Yeah. So on the indoor side, they're already fit in the palm of your hand. And that's
because you have simpler antenna requirements.
Yeah, it's about the size of a Wi-Fi AP, and it radiates maybe half watt of power. So it's a fairly low power.
So from a point of view of coverage and getting the fiber, Rob, it seems like a company like Comcast already has the fiber everywhere you'd want.
We have a lot of
to
fiber.
a large extent to do millimeter wave small cells. So what's your view on the technology for a cable
We
cut?
certainly have a lot of fiber. Certainly have a lot of coax. There's really big numbers that I don't always have off the top of my head about how many route miles of fiber we have and how many colors are on each fiber, et cetera. But as these guys have pointed out, millimeter waves, not real fond of buildings or leaves, don't really like air all that much either. So to actually cover a region requires a lot of density, and the numbers that they were throwing around point out that density. So we certainly have a lot of what we call nodes, HFC nodes, out there. They're connected. They're basically fiber to coaxial transducers today. As we go forward and look at architecture evolution, they get a little smarter than that. as we start to distribute our architecture and we start to actually have convergence between wireline and wireless, what those architectures look like in the future. There's certainly, from our standpoint, it behooves us to look at exactly what you're talking about. How much fiber do we have? How many access points do we have? How many splice cases do we have? Where is it all? It's certainly municipality dependent on how simple or not it is to do build outs there. San Francisco, New York, Philly, DC, Metro here. Versus, Houston, for example, or Atlanta, very different. Folks who do this for a living know exactly where it's easier to get this kind of work done or what the rules are, and they're different in different states, of course. But from our standpoint, we have to take a really hard look at the inventory of our fiber that's in the field, how it's utilized. We use it for residential services and business services. We have cable services on it. We have Ethernet services on it. So all of those things are in play as we look at our architecture, how to make the best use of the investment we have in that asset. And of course, we're pulling, again, for 20 years since DOCSIS has been out there and narrowcast services, as they call them, on-demand services, for example, for video. We've been pulling fiber deeper every year just for the maintenance of the capacity growth. It's just something we do. It's just a lever we pull whenever we need to, and we know how to do it very well. This gives us, every time we do that, we have an opportunity to think about what's the smartest way to pull that fiber the next time, right? And if 5G is a business opportunity for us the next time, then we think about making sure that we allocate the right resources to do that and build out the right infrastructure to do that. But yeah, we have a lot of fiber, a lot of connectivity options. The IAB thing, I think, is going to be essential. Is it IAB? Is it 3.2?
Yeah.
Yes.
I think that'll be essential to making millimeter waves effectively work and cover the region that you want, because we have a lot of fiber, but having it absolutely everywhere you need a small cell, that'll be a challenge at those kind of densities that the folks talked about here. But we can take inventory of where our nodes are and what the coverage ranges are and do those models and build a plan accordingly.
Thanks. Dave, when you and I spoke in our call, you had mentioned something called LTE NR spectrum sharing. Is that going to be another technology that simplifies 5G rollout? What role will that play?
Yeah, so in a number of the different rollouts of different generations, there's been new spectrum you could go into. Mm-hmm. So when we started rolling out LTE initially, we had 700 megahertz spectrum, which we had not yet used. So we were able to start our rollout there. We've talked a little bit about some of the Sub6 GHz bands that we're going to be looking to use, and was mentioned that the CBRS band, or 3.5 gigahertz, is one band that's a possible use. But the other thing that we're going to need to do is begin using NR in the bands we currently operate in, just like we do when you transition from any generation to the next. What you don't want to do, and makes life hard, is if I take a given channel and say, all right, I'm going to take LTE out of that, all of the customers who are using that channel, they're going to have to crowd into the other existing LTE channels. And I'm going to bring this band up for my first NR user. So one of the things we've developed and is being brought into NR in 3GPP, we call LTE NR coexistence. And it's a technique whereby we can dynamically allocate resources to LTE or to NR in the same channel, depending on what the current demand is. So that's going to make transitioning to NR in the sub-6 gigahertz band much easier, more cost-effective for us, and preserve the level of service that we're providing to our customers. Because whenever you have to move all of them out of a 10 meg or 20 meg channel onto some other channel, then obviously your load goes way up there, performance drops, and that's what we want to try to avoid. So that coexistence capability within NR should help us do a much smoother transition.
So my understanding is that 5G and LTE are really being designed to coexist very closely, and LTE will be around for quite a few years. Is that?
Yeah, it certainly will. LTE is going to be here for quite a while. You know, there's capability today, even though we talk about massive MIMO or massive machine type communications and the capability that 5G has with that, LTE still got a lot of runway to handle that with Category M devices, with narrowband IoT. At some point you're going to go beyond the capability of LTE to handle it because it's a connected concept there, whereas with NR it's a non-connected concept, and so we can really increase the density. So there will be a point where we want to do that, but LTE can handle a lot of these needs for a long time. That will also help us make that transition a little smoother because you don't have to do it right away to get specific services. Where NR really is going to shine is in the low latency. And so as low latency applications become important, we will need to be sure that we have NR in the sub-6 gigahertz bands, and that will drive a lot of that deployment.
So how low will the latency be?
Well, we're looking at a millisecond over the air kind of latencies. Now, LTE in release 15 is also looking at latency reductions, but it can't go as low as we're driving with LTE, or I'm sorry, with NR.
So a number of you have mentioned the 3.5 gigahertz band. What role might that band play for 5G? For anybody who wants to.
I think it can be a combination of both coverage, because it is in the sub-6 gigahertz band, and capacity. I think to get really wide area coverage, particularly as you start getting into less dense areas, you're going to want frequencies below that. But because
So is it like a stepping stone band to small cells, or would you?
It's a new band. So you could use it in a small cell, you could use it in macros because of some of the design characteristics of NR. You can get reasonable range with 3.5. Of course, the power limitations are going to limit that somewhat. So you're going to want to go into lower frequencies to get higher power and get wider area coverage. But it could operate in both a macro and a small cell environment and be able to serve fixed wireless as well as mobility with that band.
Maybe one more thing to add is 3.5, because it's a new band, is a new opportunity. So if you're going to roll out new systems, you might see them coming there first. And then the other piece of that is that it's right at 3.5. It's a band where you can build a very large array because the wavelength is smaller than 700 or gigahertz. So the number of elements is spaced by half the wavelength. So that's at a reasonable size. That's not too big. It's maybe about this big. You can build a 8 by 8 panel of elements. And there's aspects of NR in terms of the ability to support massive arrays is one of the things that it brings to sub-6 gigahertz. Because it was built for massive MIMO from the very start, a lot of the overhead that's associated with the lower frequencies and let's say LTE release 8, 2010 LTE release isn't there. So you can be more efficient. I mean, and what does that massive MIMO really mean? It means that we're tailoring the transmission for a location, spatially multiplexed. All the things that we need to acquire that signal. There's these reference symbols that we need to understand. What does that channel look like to you? That can all be beamformed, and that's unique because that overhead is now lower with NR. That improves also the sub-carrier spacing. We can pack. We have carrier aggregation in LTE. We get a little bit of efficiency because we can pack them a little bit tighter. And then the MIMO is a bit advanced in NR. We have
Actually,
better.
did we define what the abbreviation NR means?
I'm sorry. So
Yeah, new. It's a very fancy term, new radio.
Never let
For 5G.
engineers name things. Long-term evolution.
Anyway, sorry,
New
Marc.
radio.
Yeah, well, I think it's actually that term's been around. So it's LTE is new radio, I guess. So it's 5G as well, and G Node Bs and all that fun stuff. But so 5G new radio. You hear NR, you think 5G, just replace them. It's pretty much what it is. And if you look at the standards, you're going to see the term NR, and that's going to define 5G. So what NR lets you do is it lets you pack things tighter. If you had carrier aggregation in LTE, you're going to be able to use those spaces in the middle. So all these little things add up, but I think the biggest benefit is the reduced overhead and then better code books. We're going to be able to use those 32 element arrays much more efficiently.
I think it will be interesting as well if you haven't seen the Nokia and Google video on the test case of 3.5. They did it at racetrack. It's really kind of compelling, and it starts to spell out kind of the the new use cases as well for this, which I think get really interesting at an enterprise level of what an enterprise could do with 3.5 to the extent that they participate in how this is going to be segmented and auctioned and all of those things. So I think it gets really interesting on how this will be used differently than a traditional carrier model as well.
Is it on your roadmap for indoor?
Yeah. Well, the other thing about 3.5 gig indoors is the nirvana for a lot of enterprises is one system, where no matter who you come in the building with as far as your mobile operator, you can connect to the network in the building and go back to the correct mobile core. And that's, people don't want to install, 4 networks in the building right now, but that's kind of the state of affairs. So within CBRS and potentially evolving into the 3.5 gig NR, you have the potential that you have some places where you have shareable infrastructure elements that the enterprise can acquire and run in concert with connections to all the different mobile cores. So it could really improve the economics of providing services in the buildings by, sharing the cost of one infrastructure among 4 players instead of building out 4 pieces of infrastructure.
Okay. I'm going to ask one more kind of broad question, and then we'll see if there are any audience questions. What will the role of unlicensed spectrum be in 5G? Will 5G support unlicensed spectrum?
I think that it'll end up supporting unlicensed spectrum. It may not be the priority right now. But just like LTE moved to LAA, I think we'll see something similar to that with NR as we move forward.
So would you basically take the LAA approach mechanisms and then migrate those into a 5G enviment?
I don't know what the details will be,
Yeah.
whether it's LAA type of mechanism or something different, but I think something in that ballpark is what will end up happening with NR as well.
So LAA is LTE licensed assisted access, where you can actually run LTE protocols in an unlicensed band and then combine it with a channel in a licensed band to augment capacity.
Right.
So that would be a release 16, like a subsequent release of the 3rd generation partnership project specifications, or further down?
I'm not certain where that's going to end up in the releases. I'm not sure. Maybe somebody else knows.
Yeah, actually, I don't know. It's not there in the first release. I think it's going to be there. I think, but we've just gotten done recently with LAA and multi-fire, so we're going to be rolling out 4G and unlicensed. And I think as when we started this conversation, we're trying to use all these different assets because that continuing compounding demand is what we're trying to drive through. We're offloading from our licensed spectrum to unlicensed. I think it would be very natural for 5G as we come back and we start to reuse some of the spectrum that is 4G. We'll look at for those new applications, right? So those new verticals, those new ultra reliable, low latency type communications, lower latency. We'll certainly bring them to unlicensed. I think the term of priority. I think for the most part, 5G we're just getting started. We're working on massive broadband, non-standalone. We have a lot of new features that we're going to bring to the next releases. We expect to have 5G evolve and grow and deploy out through 2030. So it's just getting started. These features will come in. I imagine that 5G unlicensed will come in. The precise timing is unclear.
Yeah, if you think about it, where we just finished release 14, right, of the 3GPP specification, LTE initially rolled out in release 8.
Yeah.
So there have been 8 through 14. That's 6 different versions of
and it
enhancement.
continues to be developed as part of release 15, release 16, or continued evolution of LTE as well.
Yeah, so LTE continues to evolve. It doesn't stop, and 5G will evolve through the 2020s.
One thing to be mindful of with unlicensed spectrum is you have a gatekeeper. It's generally the network manager that controls the physical facilities within the enterprise community. And we've seen a lot of rejection of strategies of the operator bringing in something that operates in their spectrum.
Right.
So
So that you're saying there may be greater resistance for using unlicensed within an enterprise environment?
We've seen prohibitions and we've seen people that are okay with it.
I see.
So,
Okay.
so you know, it's the paradox of unlicensed is the network manager thinks it's licensed to them in their building.
It's sort of it, right, just by physical control of the building.
Yeah, exactly.
Are there
wanted
audience
to-
questions? If there are, you please write them down on a card.
Yeah, Peter, one other comment I thought
Yes.
it would be important for us to make when it comes to, as you're thinking about the difference between LTE and NR. LTE was primarily designed for mobile broadband. And as we've tried to move it forward, we've seen needs for machine type communications and so on. We've tried to add on, we try to fit it in and figure out a way to do things. And sometimes that means you carve off part of the spectrum from what you're doing with broadband in order to do the massive machine type communications. One of the real key goals of NR was to be able to do the ultra reliable, low latency machine type communication, the massive machine type communication, which may be a few bits every 4 hours or something, and do broadband and do all of it in the single radio protocol. So it's very flexible and it can be dynamically allocated to those different services as they're needed. The other real trend right now is to move towards software-defined networks. So as you move to software-defined network, software-controlled, and virtualized networks, we're pushing that out through the core and into the RAN so that end-to-end network slicing, the ability to define what that service or that user needs and allocate resources using the same physical resources, but allocate the resources as they're needed and are most efficiently used for that user or that service can be done. So it's going to increase some efficiency and it's going to increase the ability to make these services and new services operate with NR without such pain and suffering that we've had to go through in a sense with LTE. So I just thought it was important for us to bring that out as well.
Okay. All right. All right, these are good questions. Well, what will be the role of macro in 5G? If we're deploying all these small cells, do we still need the macros? What role will they play?
Macros will still be there in 5G. I think when we look at the lower frequencies, when we look outside of the city center, we'll continue to use the sub-6 gigahertz bands to provide 5G. And that's why we're looking at, as Dave was mentioning, that we would provide 5G in the existing 4G bands. We want to provide those low latency services. We want to provide that machine type communication efficiently. So as you go out from the more densely populated areas, you're going to tend to use larger cell sizes for the economics of it. And in those cases, you're going to have areas where you have enough spectrum, sub-6 gigahertz, to serve the demand that you see. Now, it's in the places where the city centers, the dense urban areas, where you're going to move to the smaller cells and the higher frequencies.
Yeah, we talked about this a little bit at dinner. 5G is not small cells, and small cells are not 5G. They're right. a way of deploying 5G, and so you'll still have a robust macro network that's providing the coverage layer, and then small cells that really take care of the additional capacity needs.
So one question, since it was brought up, was whether you could explain in more detail what network slicing is and how important is it to 5G?